Alright, so you may have heard of Schrödinger's cat. The experiment is this. A cat is placed into a sealed box with a radioactive element that has a chance to decay and a chance to not decay. Now also in the box is a Geiger counter, which is a tool that measures any radioactive decay going on. Now, if the Geiger counter detects any radiation coming from the radioactive element, it activates a hammer, and the hammer smashes down on a vial of poison inside the box, which kills the cat. Now, if we open up the box, there's a chance the cat will be alive, and there's a chance the cat will be dead, depending on whether the radioactive element decayed or not. But what about when the box is closed? Well, according to quantum mechanics, the cat is both alive and dead at the same time. How is this even possible? Well, to understand how this works, we need to go way back in time to 1935 to understand what the heck was going on. So before we go any further, I want to talk a little bit about the creator of the Schrödinger's cat thought experiment, a man named Erwin Schrödinger. Schrödinger was an Austrian-Irish physicist who contributed to fields such as quantum theory, thermodynamics, general relativity, and cosmology. Schrödinger received the Nobel Prize for Physics, yet he also discussed topics in a variety of other areas, such as consciousness and free will. So 1935 was one of the birth years of something called the Copenhagen interpretation. Now, the Copenhagen interpretation was one of the very first models to explain quantum mechanics. The Copenhagen interpretation can be attributed to the joint ideas of two very important physicists. The first is Niels Bohr, whose name you might recognize from his work on atomic structure. And the second is a man named Werner Heisenberg. So there are also a few general features of the Copenhagen interpretation, and one very notable in the context of Schrödinger's cat, and it is as follows. Material objects on a microscopic level do not have definite properties prior to being measured. Quantum mechanics can only predict the probability distribution of a given measurement's possible results. However, the act of measurement affects the system, causing the set of probabilities to reduce to only one of the possible values after measurement. This is known as wave function collapse. So let's explain this using some simpler terms. Basically, a quantum particle doesn't exist in one state or another, that would be too easy. It exists in all of its states at once, which is called the particle's coherent superposition. However, if we observe the particle, the superposition collapses and it's forced into only one of its possible states. So how does the Copenhagen interpretation relate to quantum mechanics? Well, when the box is closed, after a certain amount of time has passed, the cat is both dead and alive at the same time, according to the Copenhagen interpretation. However, when the box is opened, or in other words, when the cat is observed, the cat is forced into only one of these states, either dead or alive. It can't be both when you're looking at it. Schrödinger produced this silly thought experiment to show the problems with the Copenhagen interpretation. When does a quantum superposition stop existing as a superposition of states and become either one or the other? If the cat survives, it only remembers being alive, which would suggest it was always alive and not both dead and alive. However, the Copenhagen interpretation of quantum mechanics states that the cat was both dead and alive during this time. It only truly became alive when it was observed. This is Schrödinger's paradox. As Schrödinger created this thought experiment to show the problems with the Copenhagen interpretation, other quantum mechanical theories have been discussed to provide a solution. The many worlds interpretation states that the cat is both in dead and alive states after observation, because there are two worlds, one in which the observer sees a dead cat, and another world where the observer sees an alive cat. Object collapse theories state that superpositions, such as a cat in both a dead and alive state, are destroyed spontaneously because the cat and the environment around it can be considered observers to the situation, and thus the cat cannot be in more than one state at once after being observed. There are many other theories that propose solutions to this paradox, and yet no definite answer has ever been reached. Maybe, someday, physicists will come to a universally accepted solution to the problem. Who knows? Maybe it could be you.